We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Dear student, today in this video we will discuss slab-based foundation. What is the design procedure for slab-based foundation and solve one example of slab-based foundation. Before we start the example, what is slab-based foundation? So slab base is also known as column base, are important joints which not only take care of force but other aspect also. So which are these aspects? First one is alignment of column in plan. So we make the same alignment of plan of column to maintain or providing the slab base. Second aspect is verticality of column. We maintain the verticality of column throughout the height, or you can say plan, to providing slab base foundation. Third and most important aspect is control the deflection of column and beam. So it can also maintain the deflection control while it occurs in column and beam. So base plate are used for transferring the load from column to its foundation. So base plate is reducing intensity of loading and distributing it over the foundation. So it means it a intermediate stage of column and our foundation, or you can soil. So the load are transferring towards the column, are distributing and then transfer to the soil. So the base plate is chosen that the intensity of load distribution is less than the bearing capacity of concrete on which it resists. So we also know the design of concrete block. So initially the column load is distributed over the base plate and the supporting concrete, and finally the soil below the such that bearing capacity soil is exists. So mainly 3 stages. Column are transferring the load of base plate, and base plate are transferred to the load of concrete block, and concrete block finally transferred to the soil, or you can say our foundation. So there are the main 3 types of column base are used. First one is slab base, second one is gusset base, and third one is pocket base. But in general we can use slab base foundation. So before we go for the design procedure, there are the few points you kept in mind for designing the slab base. Please note down. First one, in this type of base, steel plate is sufficient thickness is placed below the steel column. So here the thickness of base plate is very important while choosing the steel column base. Second, column is connected to base plate using fillet weld all around the column section. So we'll provide fillet weld all around the column section as per the clause 7.4.2.2. Third aspect or third criteria, a concrete block is provided below the base plate to transfer the load of column to the ground. So concrete block is intermediate between column base and ground. Normally the slab base foundation is provided for the column subjected to axial load only. So the connected of base plate to the foundation of concrete, we use 4 number of 20 mm diameter J bolt with 300 mm long anchor bolts are provided. So now next is our minimum thickness of slab base. So as per the equation is given, the minimum thickness of rectangular slab base supporting column under axial components cell B is denoted as TS, thickness of slab base, under root of 2.5 W S square minus 0.3 times B square multiplied by partial safety factor divided by Fy, and the value shall be TS it less than of TF. TF means thickness of flange. So our thickness of base plate should be less than thickness of TF. While W is uniform pressure below the base plate, A and B, here you have to note down, A and B are the projection respectively slab base of larger and smaller side. And TF, that I know that TF is flange thickness of compression member. Now we start first example of slab base foundation. In that, first write down the data given for the slab base. Design of slab base foundation for column ISHB 350 to carry factored axial load of 1200 kN. Assume Fe410 grade of steel, M25 concrete. Take shape bearing capacity of soil 200 kN per meter. Here the shape bearing capacity, it means SBC of soil. So first we write down the steel property according to steel table for ISHB 350. So for that we noted down H is equal to, it means height is equal to 350 mm, BF, it means width of flange 250 mm, TF, thickness of flange 11.6 mm, and TW 8.3. Our first step, to calculate area of base plate. For that we can use clause number 7.4.1, page number 46 in IS 800 2007. So PU, total factor load, is given to you. So bearing strength of concrete is taken as 0.6 times FCK as per the codal provision mentioned here that. So our FCK is 25. So we know that bearing strength of concrete 15 Newton per mm square. Now we calculate area of base plate. So area of base plate is equal to total load divided by bearing strength of concrete. So we know that the bearing strength of our concrete 50 Newton per mm square and converted into the load of Newton. So we can add into 10⁻²3. So finally we got the area in mm square. So in our case 80,000 mm square, 18,000 mm square is calculated. So for that we choose size of built up column. So we provide I section in a horizontal, or you can say I provide in landscape direction. So our height, it becomes width of column, and our depth, it becomes width of flange. So our B is 350 and D is equal to BF, which means 250. So providing 50 mm equal projection in all around the column of width plate. You can see the figure here. A and B is noted. A is one side of projection, B is another side projection. So in our case we should provide both are same. It means A is equal to B. So 50 mm equal projection all around column are provided. So what about the new width of column? So 350 plus B plus B. It means 350 plus 50 plus 50. So it should be 450. And what should be the depth of column? New depth of column. So 250 plus projection of another side and plus projection for next side. So 250 plus 50 plus 50 is equal to 350 mm. So now use base plate of size 450 by 350. So according to column size we can calculate base plate to adding the equal projection in both sides. So our gross area of base plate provided by 450 by 350 and overall area of this base plate is 157500 mm square. So our next step, after calculating the gross area of base plate, we shall provide thickness of base plate according to clause number 7.4.3.1, page number 47 in our IS 800. So our larger projection A is 50 mm, our smaller projection B is also 50 mm because we should provide 50 mm equal projection. What should be the W? W is uniform pressure on base plate. Is calculate total load divided by area of base plate. So total load is given in our data and size of base plate we decide in our first step. So W is 7.62 Newton per mm square. Thickness of base plate is denoted by T. So now our third step is welded connecting column base to the base plate. So now in this step we connect the base plate and column through welding. So as we know the key point of our slab base, we use 6 mm fillet weld all around the column section to hold base plate in a position. So total length of available of welding along the periphery of ISHB 350. There are 12 ends of ISHB. So we know that in the welded connection we deduct the end return. So here in ISHB you can see that figure 12 end are generated. So we deduct 12 end multiply by 2s. 2s is field deduction for one end. So at the end of total deduction we calculate 144 mm. So effective length of weld available, total length available is 1683.4 minus deduction 144. So finally effective length we calculate 1539.4 mm. Now capacity of weld per mm length. So capacity of per mm length we calculate 0.7 times S into FWD. S means size of weld. So we assume 6 mm fillet weld. FWD. So for soft welding we can take stress of weld 189 Newton per mm square. So finally we know that per mm length of weld 793.8 Newton per mm. It means 0.79 kilonewton per mm. So required length of weld is equal to total load divided by per mm length. So we found 1512 mm, and in our case we should provide effective length of 1539.4 mm. It means our assumed size 6 mm of weld is adequate. Otherwise you should go for higher welding size. It means you have to change your assumed weld size if the check is not okay. Now next step, decide the size of concrete block. After connecting base plate and column we should decide size of concrete block. So the axial load of column we can transfer 1200 kilonewton. So converted into the working load. So divide by partial safety factor 1.5. So finally we know working load 800 kilonewton. Add 10% of self weight of concrete block. Here we have to assume that 10% of self weight of concrete block. So 800 kilonewton converted into the 10%. So finally 80 kilonewton. So total load we can carry as a working load. It means 800 plus self weight of column 80. So total 880 kilonewton. So the area of concrete block required, total load divided by SBC of soil. Now we can distribute this load to the soil. So total load divided by SBC of soil. Here you can mention that, or please note it down. Total load, it means you have consider working load, not take a factor load. So in given data the load is given as a factor load converted into the working load before we calculate the concrete block required. So 880 divided by SBC of soil. So finally we shall calculate area of concrete block 4.4 meter square. Now concrete block is designed for working load considering rectangular concrete block with equal projection beyond base plate. Why considering rectangular? Because our base plate is rectangle. So below that concrete block is also provided as a rectangle. Now we can decide the size of L and B of our concrete block. So we know that total area we maintain 4.4 meter square. So area of concrete block is equal to L by B. So what should be the L? So first you mention the dimension of base plate 0.45 by 0.35 meter. So now we calculate L. So what should be the L? 0.45 plus x plus x. It means 0.45 plus 2x. Same way in the width, or you can say B. 0.35 plus x plus x. It means 2x. So converted into the one equation of x square and solve in this equation, you get the two value of x. One is positive and one is for negative. B square minus 4ac under root 2a. So x is shall be calculate 0.84 meter. Using the calculator also you have to directly solve this equation and found the value of x 0.45. Now put the value of x in the L and B equation. So finally we found L is equal to 2.15 meter, B is equal to 2.05 meter. Now we can set our size of concrete block. Here you have to note it down, this step for deciding the size of concrete block. So finally our concrete block providing 2.15 meter by 2.05 meter. It means the area is 4.407 meter. What should be our requirement area? 4.4 meter. So our size of concrete block is okay. Now this is the two size L and B. We still pending our depth of concrete block. So how it's calculate the depth of concrete block? So we know that our projection X should be 0.85. We calculate to solve this equation. Take 45 displacement angle at the end of column base. So at that time value calculate or take the angle of 45 degree. So the depth of concrete block D is equal to same as X by using the triangle principle. So D is equal to also X, it means 0.85 meter. So finally we decide all the three parameter of concrete block: length, width and depth of concrete block. So here you can see the figure. First we describe the section. D should be provided 0.85 meter. It should be the concrete block, and here you can see that size of concrete block 2.15 by 2.05 by 0.85 meter. So first our concrete block is connected to our base plate. So base plate also we decided 450 by 350 by 14 mm. So base plate are connecting through the welding of column. So these are the three main stage. Our column should be connected base plate, and base plate should be connected concrete block. So how calculate the base plate connected to the concrete block? So using 4 number of bolt of anchor bolt, you can see in figure. It's the size and dimension of anchor bolt are fixed, so doesn't worry about the calculation of anchor bolt. You can see also in plan we connected base plate to our column in periphery of 6 mm fillet weld. So these 4 steps you can follow to design of slab base, and it should be a trial and error method. So before you providing the base plate size and area of concrete, it should be mention of our Gilo criteria. Thank you students.